Welcome to my projectbazaar.com.
Now let us discuss about the improving latency and reliability in 5G Internet of Things networks. Let us discuss about the abstract of the product. So recently the combination of massive multi-input and multi-output, that is MMIMO, and spatial modulation, so that is SM systems, referred to as massive and MIMO systems, has been considered as key 5G cellular technologies for increasing the reliability of multiple terminal transmission. So each terminal is equipped with multiple antennas and encode its transmitted bits by using the SM technique. With SM, the information bits of each terminal it's split into two bits blocks. So the first block is used to select the transmit antenna, while the second block is encoded as modulated symbol drawn from a standard constellation diagram such as MQAM schemes. So the zero forcing equalizer is a type of linear equalization algorithm. It is used in the communication which applies the inverse of frequency of the channel. So in this proposed work, the terminal from the IoT terminals to the cellular base station about the state critical infrastructure such as a smart grid requires high reliability and low latency. So the combination of massive MIMO and a spatial modulation system, referred as a massive spatial modulation MIMO system, has been proposed in 5G cellular network to support all the transmission of the process. Let us discuss about the flow diagram of the process. So first of all, generate the input data. So here we are using the input data randomly, and then the output is generate the input data. The randomly generated output is given to the conventional encoding data. So here we are using the encoding data by encoding the bits, and then it's going to the serial to parallel conversion. So in the step of serial to parallel conversion, it should be converted the serial bit stream into the parallel, and then interleaving coded data. Here we are using the interleader coding data for a particular process of serial to parallel conversion, and then binary to decimal conversion. So all the values in the binary streams, and then that is converted into the decimal conversion of the process. So here we are using the QAM modulation, that is a quadrature amplitude modulation, and then compared to the other modulation technique, QAM is best and efficient also. And then here we are using the pilot carrier insertion. So pilot carrier insertion means it will transmit the signal to any other deviation in the process, and easily to get the efficient of the process of the important of the technique. So next of all, the IFFT process, so inverse fast Fourier transform, that is applied to the transmission side, and finally adding the zero padding technique. So here we are using the zero padding technique. The system it should be efficient, so adding 0 in the IFFT process. Here we and then channel. So in the channel model, here we using the AWGN relay fading channel. So that is a additive white Gaussian noise process, relay fading channel of the process, and then it should be removing the zero padding. And then the receiver model, it should be the inverse of the transmission model. So here we using the remove the zero padding, and then adding the zero forcing equalizer. So here we using the ZF equalizer, it should be added, and then it's converted to the FFT process. So FFT means that means fast Fourier transform. So here we using the fast Fourier transform, and then pilot removing. The pilot removing, it should be converted, so to remove the values of the particular process. And then here we using the demodulation. So demodulation technique, the QEM demodulation technique is this. That is a Q mod is a inbuilt function of this process, and then binary to, again it should be converted binary to decimal to binary system. So then only the de-interleaving data it should be performed. So all the values should be converted again as the binary value, and then de-interleaving data is applied, and then vector B decoding. So here we using the in encoding process, here we using the conventional encoding, and in the decoding process, here we using the vector B decoding of the process. Finally calculating the bit error rate and signal error rate of the process. So bit error rate is very much low compared to the existing of the process, and also a symbol error rate. So both are calculating by using this model. So this is the transmission, channel, and receiver model. So these are the overall flow diagram of the process. Now we let us discuss about the running procedure for the process. So click the main file and then run. So click the main file and then run. So it has some times to display all the outputs of the process. In this first figure, that is outage probability comparison between the different decoding schemes. So these are the different decoding schemes. That is a massive SM. So that is a spatial modulation MIMO, spatial modulation Again, ZF, that is a zero forcing equalizer. So ZF scheme means zero forcing equalizers of the process, and then MRC scheme. So compared to all the process, massive spatial modulation, multiple input and multiple output, that is the outage probability should be very low compared to all the existing system of the process. So these are the SNR. So SNR versus outage probability of the process. So it is 10 power minus 4 compared to all this decoding scheme. 10 power minus 4, it should be minimum low of the process. So this is the decoding scheme between all the other comparison, the MRC. So there is a maximal ratio combination, and then that is the same process. So massive SIMO, different techniques to calculating the value of the process. So this outage probability versus SNR of the outage probability comparison between the different decoding scheme of the process. So in this figure, SINR performance varies NR. So that is a number of receiver when K is equal to 2. So number of receiving antennas at the base station. So this is a 4 antennas, 6, 8, 12 up to 20. So these are the number of receiving antennas at the base station, and average receiving antenna SNR gain from the each channel. How much each channel it should be gain. So comparing to all the scheme, the massive MIMO it should be high. So that is the process of, so the gain should be normally it should be high. So only the process it should be efficient. So compared to all the existing method, the massive spatial modulation MIMO concept it should be high compared to all the performance. So in this figure, the calculation of the process is number of receiving antennas. So how many receiving antennas are present in the base station, and then the gain should be efficient. So average receiving SNR gain for the each channel in the case of dB. So that is the process of the SNR performance for various number of receiving antennas when K is equal to 2 of the process. Yeah, and then in this figure, the number of receive antennas at base station, same process, similarly to the yearly graph. So that is a figure 2. Compared to the graph, SINR performance for varies NR when K is equal to 4. Comparing to when K equal to 2, this is when K is equal to 4. Compared to all the process, the massive SM MIMO concept it should be high. So whatever it may be, when K equal to 2 or K is equal to 4, so the massive MIMO concept it should be high. So that is the average receiving SINR gain of the each terminal. The number of receiving antennas at the base station should be high of the process. So the SINR performance of varies. The NR when K is equal to 4, it should be high of the process. Similarly, this process is calculating number of receiving antennas at base station. The same process by baseband processing delay, the various of NR when K is equal to 2 and K equal to 4, whatever it may be, the same graph it will be displayed. So when K equal to 2, these are the values, and when K equal to 4, these are the values it will be displayed. So compared to all the process, the processing delay of each subcarrier, how should be the processing scheme? It should be display of the process. So compared to the MLD scheme, the processing delay should be very much low compared to the existing method. So these are the overall running procedure for the process.
Thank you for listening this video.